welcome back. We're going to continue with vectors. We're going to talk about operations of vectors or with vectors. Yesterday we talked about one, really we talked about addition of vectors. Today we're going to continue and talk about a few others, okay? Meaning, does a vector have an opposite vector? Some things I expect maybe you remember from geometry, maybe you don't, okay? An opposite vector. So if I have a vector v, the opposite vector will be negative v, okay? They will have the opposite direction, but same magnitude, okay? So we would write vector v and the opposite of vector v. Why that v got a little hat on it. Okay? So this is an and, not a plus. Okay? So like if I said 3, and what's the opposite of 3? You would say negative 3, right? So vector, and we have a negative in front of our vector. If we were to add these vectors together, we would get 0. Okay? We would call that a 0 vector. Okay? If we wanted to look if vector v was going this way and it had components of, let's just say, 3, 2, the opposite vector would go the other direction, okay? And it would have components, this would be negative v, and it would have components of negative 3, negative 2, okay? Meaning, if I did the magnitude on each of these, 3 squared plus 2 squared, I'm going to get, 9 plus 4, the square root of 13, right? Then the magnitude of negative v would be the square root of negative 3 squared plus negative 2 squared. It's going to be the square root of 13 also. Okay, they'll have the same magnitude, but they're going to go in opposite directions. Okay? So if we add them, what we did the other day, if we were adding vectors, we would add 3, 2, plus negative 3, negative 2, and we would get 0, 0. Okay? There's another operation other than addition. We could multiply. We call it scalar multiplication or scalar product is what they say. Okay? Scalar product means you take a vector and you multiply it by a number. Okay? So if I wanted to multiply vector v by 3, 3 times 3, 2. Or we can say 3 times v. Okay? 3 times vector v, this is called scalar product, or scalar multiplication is really what it was called in geometry. They put product, I don't know why. We simply say 3 times 3 would be 9. 3 times 2 is kind of like we're distributing it. Okay, so if I said 3 times vector v, we would put that same vector on itself 3 times, and it would now have a component of, or components of, 9, 6. Okay? The magnitude would be 3 times as much as it was on the original one. Okay? We can actually subtract vectors. Let's see. We wanted to subtract vector, I need new numbers. Here we go, I'm going to get new numbers. Vector u has components of 4, 6, and vector v has components of 2, negative 5. Okay, and what if I wanted to subtract these vectors? U minus v. My v's get a little crazy. Okay, could we really say that's u plus a negative v. Could we say that? Is it the same thing? Yes, it is. So we would take u, which is 4, 6, plus a negative v. So we need to take, if this is v, what is negative v? What are the components of negative v? It's the opposite, remember? 2, positive 5. Okay? So negative 2, positive 5. Because this is u, and this is my v. That's a negative v. So when we add them together, 4 plus negative 2 is 2. 6 plus 5 is 11. Okay? Could we put it in a parallelogram? Okay, we need to talk about the properties of parallelograms. So we can add, we can subtract, we can find the opposite, and we can multiply. We're not going to talk about multiplying vectors just yet. We'll wait for that for another day. Okay? I think this may be a 3-day intro of 7.4. Will take about 3 days, then we'll do it, and 7.5 is really short. Okay? So, you need to know about the properties of parallelograms. We're going to talk about that parallelogram rule. Property of parallelograms, I guess. Quadrilateral opposite sides are parallel. Okay, another property. Opposite sides are congruent. Okay, opposite sides are congruent. What about opposite angles? Yeah, opposite angles are congruent. These are all things that you should already know. Okay. Another one that we forget most often is about the diagonals. The diagonals bisect each other. Okay, the diagonals are not congruent. They're only congruent if it's a rectangle. Okay, that's a very special case when they'll be congruent, but not necessarily, they won't be congruent any other time, but they will always bisect each other. Okay, but they don't bisect the angles of the parallelogram. Know that. That's only in a rhombus. Special about a rhombus, they bisect the angles. These do not. So these are our properties. What we get most of the time. Okay, these diagonals, not congruent. What they do, they cut each other in half. Okay, there you go. Properties of a parallelogram that we probably need to know. Okay, so if we were to draw, let's do one last thing before we get into parallelograms. I'm not always going in the exact order of the book. I apologize. Okay. Some things I see is easier, and they see, let's do them in this order, and I don't always know. Okay? So, we have components. Vector U has components of A and B. Okay? It has a magnitude of, this is kind of a review, we did this yesterday, A squared plus B squared. It has a direction, a theta, of inverse tan of B over A. Okay? So, if you have the components, A and B, you can find the magnitude and the direction. Okay? Another thing, what if I gave you the magnitude and the direction and asked you to find the components? Okay? If I were to do that, I would simply ask. I would not simply ask. I would simply say, hey, guess what? There's a formula. If you have, if given, the magnitude and direction, you can find A and B given these formulas. A equals magnitude of U times cosine of theta. Okay? Remember, A is the one next to it. Cosine relates to the adjacent. And the B is the magnitude of U times sine theta. Okay? The sine is about the opposite, or the y value. Remember that? A relates to the x. Sine relates to the x, or the A. Cosine relates to the x, or the A. Sine relates to the y, or the B. Okay? Now, there are other ways that you can find this, and we'll talk about that another day. Well, I really think I probably should go ahead and just show you. Let's work one problem where I give you something. We did one the other day. If vector V is components, let's say 5, 2. Can you find the magnitude of vector V? Square root of 5 squared plus 2 squared, and we get 25 plus 4 is the square root of 29, correct? Your theta would be inverse tan of 2/5, which I'm going to have to pull out my calculator to find. Okay? Second tan, 2 divided by 5, 21.8 degrees approximately. 21.8 degrees. Okay? We've got our magnitude and direction. Okay? I'm going to go ahead and give you another problem of, what if I give you the magnitude of W equals, let's just say 25.0, and then my theta is 41.7 degrees. Could I find A? A equals the magnitude times cosine 41.7, and B equals the magnitude of W times sine 41.7. Those will be my components, not parentheses. They're exponents. So my A and my B. Okay? So when I plug that in, it's pretty simple. 25 cosine 41.7 and 25 sine 41.7. Here we go. 25 cosine 41.7. We get 18.66. So my A, I'm going up here, A equals or is approximately 18.7. My B is approximately 25 sine 41.7. Not too hard, 16.6. Okay, so I've got my answer. Okay. There is a shortcut in your calculator. Okay, I have to go back and find it. Oh, it's not in that one. There we go. It's second angle where we're finding our degrees, minutes, and seconds. We've used the first 4. Now we're going to use the next one. It's 5, 6, 7, and 8. If you hit number 5, R, PR, okay, if I put in 5, comma, where's my comma, 2 in that. Oh, it's going to be 5.38. What is that? What about the square root of 29? It's the same number. So if I use R, arrow, PR, it will give me the magnitude. I have to put in the components, okay? If I go back and hit second angle, we're going down to theta, go down to number 6, and I hit 5, comma 2, put in your components, parentheses, enter, 21.8 degrees. So that was my R, P, theta. Put in your components, it gives you the direction. Okay? What were those other ones I said we might use? Number 7 and 8, P, R, X, P, R, Y. What do you think that gives you? The X and the Y. Okay, so if I go down to 7, you do have to put it in the right order, and I'm pretty sure it's magnitude and then direction. 41.7, 18.665, we had 18.7. So that's my P, arrow, R, X, comma, it's simply an X. I put in my magnitude, then my direction, and it gives me the X value. If I were to go back one last time to number 8, I put in my magnitude, comma, direction, it's going to give me my Y. P, arrow, R, Y. Magnitude, direction will give you your magnitude and direction. Okay, we've done a lot. Well, there is still a little bit more to do with vectors, but I'm going to pause right now, and we will start again tomorrow. All right, guys, have a good day. I will talk to you later.